Hi guys, in today's video we are learning about quadrilaterals. So we are graduating from triangles into quadrilaterals. And so if you think about a breakdown of this word, the word quad means four. That's why like the muscles in the top part of your leg are called your quads. They have four muscles as part of the makeup of those parts of your leg. And then the word lateral means side. So a quadrilateral is going to be a shape with four sides. The specific name, not just any shape, it is a type of polygon. It's a polygon with four sides and four angles. I haven't actually defined polygon for you guys before. I think most of you guys know the prefix here, poly, like a religion that is polytheistic would have many gods. It would have more than one god. So poly is the word that means many. And then this word gon is actually the Latin part of the word for the word angle. So just a polygon, so let's talk about that word really quick. A polygon is a shape with many angles. I don't think my writing showed up there. Let me trace over that. So it's a shape with many angles. So that's what a polygon is. We've learned about a lot of polygons, probably since you were in kindergarten, you've learned about different polygons. We like to classify polygons by the number of angles that they have. So you have probably learned about triangles. Triangles have 3 angles. Quadrilaterals have 4 angles. Let's see if I can get the glare off of this. A pentagon has 5 angles. A hexagon has 6 angles. A heptagon has 7. An octagon has 8, just like an octopus has 8 tentacles. And just like October is the 8th month of the year, just kidding, I know October is the 10th month of the year, but that's because our calendar changed. Originally, for like the original calendar that named October, it actually was the 8th month before they added January and February. Nonagon is one of the coolest ones because it sounds like the number. So nonagon is like a ninagon. Decagon, I don't know if you remember when you turned 10 years old, but I was really excited to tell people that I was a decade old. I guess I'm kind of a dork, but that's, I was excited about that. And then a dodecagon is 2 plus 10. So do is 2, and then deca is 10, so that would mean 12. We actually skip 11 in high school geometry. I don't know why we don't teach you guys the name for that one. 11 is a hen decagon, like a female chicken is a hen, but we don't need to know that. And then there's also names after 12, but we don't need to know those either. These are the only ones high school geometry actually cares that you know. It's interesting, quadrilateral is the only one that has laterals in the name, which is the sides. All the other ones talk about angles. Like triangle just straight up says angle. And all these other ones say gon, like the Latin word for angle. So I don't know, I thought that was kind of interesting that quadrilateral for some reason is the only one. Like why isn't it called like a quadrigon? I don't know. Or why isn't it called a trigon? I don't know that either. Anyway, so quadrilaterals, the things we're learning about, they've got 4 sides and 4 angles. Now there's a lot of different special kinds of quadrilaterals, but I don't want to overwhelm you and talk about all of them at once. So I'm just going to talk to you about 2 different types of special quadrilaterals. So 2 special types. One of them I know you have learned about before. It is called a parallelogram. The other one I don't think you've ever learned about, and it's called a cyclic or an inscribed quadrilateral. And a parallelogram, you know, it's got this word parallel in the name, which means the top and the bottom need to be parallel to each other, and the left and the right need to be parallel to each other. So these two are parallel and these two are parallel. Remember, parallel means that they are never going to intersect and they have the same slope. So parallel and parallel, that makes a parallelogram. And then a cyclic or an inscribed quadrilateral, I think it's pretty obvious. It just means a four-sided shape that's inside of a circle. Now, the important part is each vertex of the quadrilateral must be touching the circumference of the circle. So it can't just be like drawn on the inside. It's got to go all the way to the edge of the circle. So that's what we call a cyclic or an inscribed quadrilateral. And then this guy over here is just called a parallelogram. So these are just two different types. I'll teach you about some other types later on. And I'm also going to teach you about some other properties of parallelograms in a future video. Today, I only want to focus on the angles of that parallelogram. So let's talk about these angles. I'm going to just label them with some letters. So let's call this one A, B, C, and D, right? So the rule is we would say that A and C are opposite angles, and we would say that B and D are opposite angles. And the rule is opposite angles in a parallelogram are, now if you could guess, like if you look at the size of this angle and you look at the size of this angle, do you see how like if you cut this angle out and kind of turned it and stuck it over here, do you see how these angles actually even look like what is true about them? They're actually exactly the same. They are congruent. Remember that that means they have equal measures. Sorry. So if I told you that angle A was 70 degrees, then angle C would also be 70 degrees. Same thing here. If I told you that angle B was 110 degrees, angle D would be 110 degrees. So we would call these two angles opposites and these two angles opposites. So so the measure of A is going to equal the measure of C, and the measure of B is going to equal the measure of D. Oh, sorry about that. Okay, and then the other set of angles that we have are going to be the ones that are on a line together. So like A and D are on the same line together, and A and B are on the same line together. So if they're on the same line together, we actually call them, it's the word consecutive. So consecutive angles are supplementary. And if you remember what supplementary means, it means their measures add up to, and do you remember what supplementary angles add up to? They add up to 180 degrees. So what we would say about that is like A and B add up to 180, B and C add up to 180, C and D add up to 180, and D and A add up to 180. So I'll write that here. So A plus B is 180, B plus C is 180, C plus D is 180, and D plus A is 180. So that's really all I wanted to teach you about for parallelograms today. That's talking about their angles. We will learn about some things about their sides and about their diagonals, but today just talking about their angles. Opposite angles are equal and consecutive angles are supplementary. Now with cyclic or inscribed quadrilaterals, they actually have only one property that you have to remember, and it's almost the opposite of parallelograms over there. So in a cyclic quadrilateral, let me go ahead and label this. This will be, let's say, W, X, Y, and Z. So the only property that we can say for sure about a cyclic quadrilateral, we can't actually say anything about the angles that are consecutive. There's no rule for them when they're inside of a circle. But what there is a rule for is the opposite angles, and the rule is that opposite angles are supplementary. So that's kind of crazy because it's very different from the rule over here. In a parallelogram, your opposite angles were congruent. But if it's inside of a circle, the opposite angles are actually supplementary. So that would mean that W and Y add up to 180, and that X and Z add up to 180. And that's the only rule that we have for cyclic quadrilaterals. So what you're going to have to do when you're doing a problem is decide, is it a parallelogram or is it one of these quadrilaterals that's inside of a circle? And there's going to be two different ways to solve those problems. So I have 3 examples that we'll go over, and then you should be ready to solve some problems. So let's start off here. We've got solve for the measure of angle ABC. So the first thing I need you to do is figure out what angle ABC is. So ABC, remember we want to focus on that middle letter B. So angle ABC is this one right here. So I'm going to put a question mark there. And it tells us that angle DAB is 113 degrees. So DAB, remember, you want to focus on that middle letter, DAB, so that's right here, is 113 degrees. So are these two angles opposites or are they consecutive? So because there's one right after another, these are going to be consecutive. Oh, I apologize. I forgot. This problem is supposed to have little arrows to show you that it is a parallelogram. Sorry about that. So it is a parallelogram. We can see there's no circle around it. So we're going to use the rule for our parallelogram, and we're going to use our rule for our consecutive angles. So consecutive angles are supplementary. That means when they're right next to each other like that, they're going to add up to 180. So we're going to say that 113 plus the one we don't know is equal to 180 degrees. So all we have to do to solve that is do 180 minus 113. And that'll give us the answer. So that answer should be 67 degrees. All right, so the next question is another parallelogram. And in this parallelogram, they ask us to solve for angle EFG. So remember, we focus on that middle letter, EFG. So I trace from E to F to G. So this is the angle EFG. And they told us that the angle EHG is 59. So EHG here is 59. So these two angles are opposite angles. My shape is a parallelogram. So because I have opposite angles of a parallelogram, I can go up here. Opposite angles in a parallelogram are congruent. So I don't even have to do any work. I can just say that my answer is that angle EFG is 59 degrees. So that's a pretty easy one. And then for my last example, I do have one of those cyclic quadrilaterals. I can tell that it's a cyclic quadrilateral or an inscribed quadrilateral because obviously there's a circle around it. And they asked me about angle X. So the rule with our cyclic or our inscribed quadrilaterals is that opposite angles are supplementary. So if we're talking about this angle right here, and I look across at the opposite angle at 88, I know that these two opposite angles, unlike the parallelogram where they are congruent, whenever they're inside of a circle like that, they're actually supplementary. So I would say that X plus 88 equals 180. So to get my answer, I would have to subtract 88 from 180. So I would get that X is equal to 92 degrees. All right, so thanks for being here. Just to recap, we learned about quadrilaterals. Those are polygons with 4 sides and 4 angles. Specifically, we learned about 2 different types. The parallelogram, which has 2 pairs of parallel sides, which has opposite congruent angles and consecutive supplementary angles. And then we learned about cyclic quadrilaterals, which don't have a relationship for the consecutive angles. There's no rule for those, but there is a rule that if they're opposite from each other, they're going to end up being supplementary. So good luck with your lesson on Delta Math, and message me on Remind if you have any questions.